Hey guys, hi. I will apologize in advance if this is a little goofy. I'm doing this again up at the main SMARTBoard now that I've got my wireless mic, and so if the sound or if the drawing is too small or something like that, please let me know. Second set of rational functions that we're going to do is we're going to talk about is when we have multiple variables. And so, or you can have multiple variables, multiple vertical asymptotes. And the way that kind of tips you off there is that when you look down here in the denominator, you're going to end up having more than one zero that doesn't divide out. You're not going to get those removable discontinuities. So to do that, it's going to be pretty much the same steps as finding a regular rational equation. You're going to go through and factor out the bottom here. So you get x minus 3, x minus 5. And so that means that we have vertical asymptotes at x equals 3 and x equals 5. So go ahead and draw those in like what we normally would do with our regular rational expressions like we were doing before. And then what's going to end up happening is that we're going to end up, after we get what the horizontal asymptote is that we're going to end up alternating sides. We're going to like get one up here, and we'll get one down here, and we're going to kind of get another one up here. So to find out exactly where things fall, you need to obviously find a horizontal asymptote, which again, remember, you're going to take highest degree in the top, which is going to be the x term, and the term with the highest degree on the bottom, which is going to become x squared. So that's going to equal 1, reduces down to 1 over x, which then means would go to 0 as x got infinitely large or infinitely small. So we're going to have an asymptote here on the x-axis. And then from there, it's just going to be plotting points again. Now, if you remember from what we did before on rational expressions, I had said that it's important that you kind of center points around, your two vertical asymptotes. And so like for here, what I would end up suggesting to do, these are a little tight, is that you would say, okay, I have f of x, and you know that at 3, you're not going to have any values because you have your vertical asymptote. You're going to go back and still plug in 2 and 0 and 1. You're going to then, normally you go 4, 5, 6 or whatever. We're going to figure out what 4 is. I'm going to continue it over here so we can keep everything on the screen. 5, we don't have a value for because that's a vertical asymptote. And then you're going to go off and plug in about another 3 points after that and come up with 6, 7, and 8. So then, again, you're going to just plug these values in. So if I plug in at 0, I get, what, 4 over 15. So we're essentially bottoming out near the horizontal asymptote, which isn't a surprise. If I plug in a 1, I get 5 over 8. If I plug in a 2, I get 6 over, what, 4 minus 16. Well, negative 16 plus 15 is negative 1. 3, so it's like 2. Now, what's going to end up happening, again, as I said, is that we're going to end up having, so that means that we're going to have a section up here, and you'll find that with rational expressions, again, they're going to alternate kind of sections as you go. So if one starts at the top like ours is, then the next one will skip down. So at 0, we're under a half. At 1, we're at about a half. At 2, we're at 2. So you're going to know that we're going to, again, get very close to the vertical asymptote. I'm going to fly up. I mean, horizontal asymptote, we go up to the vertical asymptote. I'm going to plot out a couple of, well, I might plot out a couple of decimals here just because the two asymptotes are so close. So if I plug in a 4, I get, what, 8 on the top. On the bottom, I get 16 minus 32, so that's a negative 16 plus 15, so that's negative 1. So I'm going to actually get like a negative 8 here. Pardon me, let me just double, yeah. So you're going to actually have all the way down here. Now, it's not always going to actually be symmetric in between the two asymptotes. It's not going to necessarily look like a parabola, but we kind of know that that's where things are going to be going, and so we're going to go ahead and plot here. If you want to be really exact, I would suggest plugging in, you know, obviously in this case, like 3.5 and 4.5. The problem is that you'll be doing the asymptotes to be a little bit further away, so you'll be able to get those multiple points in there. And then we're going to go back and hit 6, 7, and 8. If I plug in a 6, I get, what, 36 minus 48. So that's a negative 12. plus 15, so that's 3. 10 over 3. If I plug in a 7, it's 11 on top. 49 minus 56 is 13, so it's 2. So like 11 halves. That doesn't seem right. 11, 49, 56. I guess, okay, it's 8, sorry. So 11 eighths, that's better. And then if I plug in an 8, 64 minus 64, okay, so 15. And then on the top I will get 12, so it's going to be like 12 15ths. So now I'm underneath 1. So when you plot those, at 6, I'm going to be at 3 1/3. At 7, I'm going to be at 11 eighths, so that's about 1 1/2. I'm going to be about 12 15ths. So now notice it's kind of interesting that in some ways this section of the rational isn't quite as steep as the other one. So again, it's not going to be perfectly symmetric with these things. But you get the general idea. It's not that different from what we're normally doing. You're going to go through and get the vertical asymptotes. You're going to plot points to the left and right of each vertical asymptote, and you're going to connect things. One thing that usually throws people is that in this section right here is that you don't always get part of the curve. Oops, sorry, I didn't mean to enlarge it. In this section right here, you don't always get parts of the curve, and that often happens. And usually, actually, the tighter the vertical asymptotes, the further away the curve is going to be. So anyway, that is graphing multiple vertical asymptotes. The last section we're going to do, which is on the next video, is graphing oblique asymptotes. So check that out when you have a chance. Thanks. I'll see you in class.